Hello, my name is Zachary Rice, and I was in group 6. I had molecule letter F. So I'm just going to start walking you through how I determined my molecular structure based off my molecular formula and data given to me. So here's my molecular formula right here, C7H14O2. And I'm just going to start by collecting a weight. So I have 7 carbon atoms. I'm going to multiply that by 12 for each individual atom, so that gives me 84. I have 14 hydrogen atoms, which are each one. That gives me 14, and then a 2 oxygen times 16 is 32. That gives me a total of 130 grams over moles. And then for my degrees of unsaturation, I'm going to go ahead and work this out. So we take our carbon and we're going to multiply that by 2, so I have 14. We subtract singular hydrogen atoms, so that's minus 14, and then you add 2 on that. With oxygen, there's nothing you do with that to help incorporate degrees of unsaturation, and then we divide the whole structure by 2. So 14 minus 14 is 0, plus 2 is 2. 2 divided by 2 is 1. So we have 1 degree of unsaturation somewhere in this molecular structure. That could mean there's 1 aromatic component or there's 1 pi bond. So just from that alone, we can kind of determine we're either going to have some kind of aromatic or we're going to have an alkene, some sort of pi bond there somewhere. So we can kind of predict we're going to have like a carboxylic acid, an ester, maybe hemiacetal, something along those lines. So we're going to start with our IR. I did input the frequencies on all of my graphs just to make this go a little faster, catch my eye a little bit better. So upfield, we have 2980 is our first frequency. That one is a CH alkane, specifically sp3. There is no alcohol present on this IR, so that is a big factor. So we can immediately rule out carboxylic acid with no OH spike. The next spike, 2890, right there, that's an sp2 CH alkane. So I'm going to go ahead and put that in. 1750 right here, this spike right here, that is a C pi bond to O, specifically an ester, because that one is a little more upfield. We can kind of rule out that it's probably not an ether. Again, we already ruled out carboxylic acid with no alcohol present. So that kind of solidifies this is most likely an ester we're looking at. And then around 1200 right here, this spike on the IR, we have a C double bonded to an oxygen with an additional oxygen coming off, which again gives us the picture of an ester formation. So that gives us a lot of data right there. Just need a little bit more to work with. And then looking at our carbon 13 NMR, we can start to decipher this one as well. So looking at 14 downfield on the NMR, we can see that we have an sp3 methyl group right here. So this would signify the end of the alkane somewhere along there. And then at 22 and 26-ish right here, we do have, again, CH2s. Those are also sp3 because they're on the lower end of that spectrum. And then again, at 26, we have that same thing. At 42 right here, this is also a CH2. It is higher up on the spectrum, a little more upfield. We can attribute this probably most likely to the electrostatic energy of the oxygen, pulling that one further upfield. Meanwhile, it's still just a CH2 on there. And then lastly, at 61 on the downfield end, this is still an sp3, but this one is a C single bond O right there, which would be the one pulling that CH up. And then this one right here, all the way outfield, would be our C double bond O. And that one would be sp2 because it is past that point. So we're going to have C double bond O. So that is our carbon NMR right there, which supports our IR and our degrees of unsaturation. I'm only seeing one double bond, nothing that indicates an aromatic, so that's all looking good. And when we move down to the hydrogen NMR, again, I pre-filled this table a little bit, so we're just going to break this one down next. So here at this chemical shift of 0.9, we have an integration of 2 hills, 2 minus 1, that gives us 1 hydrogen. The multiplicity, there's 2 hills, so that's a doublet. 1.2 right here, it looks like we have 3 hills, so we can go ahead and fill in that as a triplet. 3 minus 1 is 2, so that's 2 hydrogen. 2.2 looks like we have 1, 2, 3, 4, 5, 6 to 7-ish. I'm gonna go with 6. So 6 minus 1 is 5 hydrogens. We're just gonna put multiplet because there's multiple of them. 2.4, this peak right here, we have 2, so that is again a doublet, and minus 1, that is 1 hydrogen. And then here at 4, we have 1, 2, 3, 4 hills. So that is a quartet. 4 minus 1 is 3 hydrogens again. And then we can kind of interpret that right here with the doublet as that first methyl hydrogen. With the triplet, we have one on either side. There's our CH2. That kind of gives us a picture that we're looking maybe at a more of an isopropyl type of structure in some way. With 2.2, that's a multiplet, my apologies, got that CH. At 2.4 right here, we have our doublet structure, so you have one on either side, CH3 to CH2 on those 2 peaks. And then finally at 4, we have our quartet, so we have all 4 of those laid out. So going back to our original degrees of unsaturation, we know there's only one pi bond or aromatic. We're not seeing any indication of an aromatic ring in any way, so we can just rule that out completely. We're dealing with a pi bond, specifically an ester. So we're going to have a carbon to another carbon that's double bonded to an oxygen. Off that carbon, we're going to have our oxygen again, which looks to be in that, in the middle of that structure. So we can come up with this structure right here as our proposed structure. We have our carbon to our double bond to our oxygen with the oxygen coming off with an ethyl, of course. And then this is kind of that isopropyl structure that we were hinting at here with this triplet. And of course, this can be flipped either way. They're the same molecule. So looking at this proposed structure, our last thing to do is just to go through the data once again and verify we've met all the following criteria. So we just start with a simple count. We look at the carbons. There's supposed to be 7. 1, 2, 3, 4, 5, 6, 7. There's 7 carbons. Hydrogens, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 14 hydrogens. Looking at our oxygen, there are 2 oxygens. In that IR, we specifically saw the presence of an ester with that C double bond O, and then the O coming off of that carbon that supplied the C double bond O with no OH. So that signifies it was definitely not a carboxylic acid. We have that presence here with this ester bond. In the HNMR, the hydrogen NMR, we specifically saw the presence of an isopropyl looking structure. We do have that right here on my proposed structure. And then we see just a lot of alkane CH bonds, which of course we have on our structure with these 3 and these 3 CH2 groups, which supports the idea that this very well could be the proposed structure. So thank you for following along this data with me.